For nearly a decade, a tantalizing idea has lingered over the outer solar system, a huge hidden planet lurking far beyond Neptune. This is the Planet 9 hypothesis. Since 2016, it's been a wild ride of excitement, skepticism, and endless computer simulations. Some studies said the evidence was strong, while others claimed it wasn't even needed. But now, after years of searching, the most intriguing clue yet has popped up in a surprising place: old data from 2 space missions. Back in 2016, astronomers noticed that distant objects beyond Neptune had weirdly clustered orbits, not random at all. Their simulations suggested a massive planet, maybe 10 times the size of Earth, could be the cause. And so the hunt for Planet 9 began. Astronomers have scoured the skies and analyzed data for years with no luck. But this new candidate, it might just be the one. Stay tuned for more updates, and don't forget to subscribe. Instead of relying solely on modern missions, a team of researchers turned to the past. IRAS, 1983, the first infrared space telescope in history, and AKARI, 2006-2011, a Japanese infrared mission with improved sensitivity. Infrared telescopes are ideal for detecting very distant solar system objects. These bodies are too faint in visible light, but emit a small amount of thermal energy detectable in infrared wavelengths. The strategy was clever. Compare IRAS and AKARI observations separated by 23 years, identify infrared sources that moved slightly over that time, eliminate all known stars, galaxies, and solar system objects, and isolate slow-moving bodies far beyond Neptune. Objects that distance shift extremely slowly across the sky. But over decades, even a tiny displacement becomes measurable. That is exactly what the researchers looked for. After cleaning the data and removing all known objects, the team found a small set of moving pairs that appeared in both IRAS and AKARI, and among them one stood out. The displacement between the 1983 and 2006 observations matched what would be expected for an object. Between 500 and 700 astronomical units from the Sun, with a mass possibly between 7 and 17 Earth masses, detectable only in the infrared and faint enough to have escaped previous optical searches. If confirmed, this would be the strongest Planet 9 candidate ever identified. But this is where the story becomes complicated. Although the claim is exciting, there are important reasons for caution. IRAS and AKARI are old missions, with limited resolution and sensitivity compared to today's telescopes. The candidate's detection depends on matching faint, noisy infrared sources across different instruments and epochs. Archival analyses are prone to false positives if even one filtering step is imperfect. Because of this, the announcement was not published in a peer-reviewed journal immediately. It first appeared on a preprint server. The authors say it has been accepted elsewhere, but the community is reserving judgment. And then came the most important critique. Mike Brown, one of the creators of the original Planet 9 hypothesis, examined the candidate's proposed orbit. His conclusion: if the infrared source really is a planet, its orbital inclination would be around 120 degrees. That is far outside the expected range of 15 degrees to 20 degrees predicted for Planet 9. This means 2 things. Either the candidate is not Planet 9, or Planet 9, as originally described, might not exist, and this new object represents something else entirely. Interestingly, Brown also noted that if a second massive planet existed in that region, it would gravitationally destabilize Planet 9's orbit as originally hypothesized. So the candidate might actually refute the classic Planet 9 scenario rather than confirm it. A fascinating twist. To test this candidate, astronomers need modern instruments with enormous fields of view. Fortunately, 2 powerful tools exist or are about to come online. DECam, Dark Energy Camera. Located in Chile, DECam covers an impressive 3 square degree field at once. It is ideal for scanning large regions of sky and detecting extremely slow-moving objects. Vera Rubin Observatory. Soon to begin full operations, Rubin will use the largest digital camera ever built for astronomy. It will image the entire visible sky every few nights with unprecedented depth and cadence. Researchers plan to point these instruments toward the coordinates suggested by the IRAS-AKARI match. If the candidate is real, it should reappear and move exactly as predicted. If it does not, the signal likely came from noise or mismatched sources. Either way, the upcoming surveys will deliver a definitive answer. If this object is confirmed, it could reshape our understanding of how the solar system formed. How did a massive planet end up so far away? Was it scattered outward by Jupiter or Saturn? Was it captured from another star during the Sun's early cluster phase? Could there be more planets hidden even farther out? A confirmed detection would revive questions that go far beyond the Planet 9 hypothesis. This story is a perfect example of how science progresses. Hypotheses are made, predictions are tested, evidence is challenged, and ideas evolve as new data emerges. The new candidate is promising, but it is not proof. It is a target, something astronomers can point telescopes toward. And that alone represents progress. After 9 years of debate, refutations, simulations, and skepticism, the Planet 9 saga gains a new chapter. Thanks to infrared archives from decades ago, we finally have a candidate worth investigating. Will it turn out to be real? Is it Planet 9 or something entirely different? Will Rubin or DECam confirm it in the next few years? For now, the answer is simple. The search continues, guided by a fresh clue from the past. And soon enough we may learn whether our solar system hides a distant, massive world waiting to be revealed.